Eric Burgess here, and we've been given another sequence that they want us to rewrite an expression in the form of n. That's the goal here. Now remember, n starts at 1, and it goes up in integers. 1, 2, 3, 4, on and on and on, forever. So we're looking at this, we're looking for patterns. It's just a pattern hunting game. We notice there are negatives on every other one. We'll do that at the end. That's the easiest part of the whole problem. Looking here though, we see we have a 4, 16, and 64. And if you're fluid with your powers of 4, you notice that this is 4 to the first, this one's 4 squared, and this one's 4 cubed. So that is pretty suspicious right there. So we're going to run with that pattern. So if this pattern's true, that means that this has to be 4 to the 0, and this one has to be 4 to the negative 1. And we're writing fractions, so we'd have something like this. And we notice that for these three, 1 is on top of everything. So we've got a 1, 1, 1, and this one's negative. So is this one. So for this one, 4 to the 0, well, that's the same thing as 1. And then, so we can just put a 1 up top, and this will still be 1. So that one's been taken care of. And this last one, 4 to the negative 1, well, we take the reciprocal of this, right? Because it's a negative power, we get 4, just like we have here. So we can just put a 1 up here. And then when we take this reciprocal, we'll get 4. So this is going to be our pattern. Now remember, when we generalize to n, we're looking for this sort of a pattern where we start at 1 and go up. So here's 1, and we're counting up 1, 2, 3. Except for over here, we've got, negative 1 and 0. So what we're going to do is we're going to go ahead and shift n to start at negative 1. So if we start at 1, all we have to do is, subtract 2, and we'll be at negative 1. So this means our formula is going to look like this. We're going to have 1 over 4 raised to the n minus 2, right? Because n starts at 1, and then we subtract 2, and we'll be at negative 1. And we can begin to go forward. Now we do have these negatives on every other number, and there's a really easy oscillating sequence we can use for this, and that is negative 1, right? And when the power of this is odd, it'll be negative, and when the power is even, it'll be positive. So we go ahead and put our n up here. So as n increases, and we want our first one to be a positive. Now right now n starts at 1, right? So it's going to be an odd power, so we'll get negative 1, because negative 1 raised to the first power is negative 1. So we could shift it by 1, we could add 1. So now this will be n squared, which will give us, this will be negative 1 squared, and this will give us a positive power, and that's why this will work out. You could also write n minus 1. It'll be negative 1 to the 0, which will also be positive 1. So that would also work. I just generally go with the plus 1. And that's all you got to do. This is the sequence. So they're going to start getting a little more complicated, but you'll see a lot of the same tricks. You'll see this form of power show up, and they'll try, and the most sneaky thing that generally happens is they do stuff with shifting, where they shift things by 2 or by 1, and you've got to take that into account to make sure that things come out correctly. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.